Welcome and hello. This is a video exercise in HEC RAS, and in this exercise, I'm going to be demonstrating ineffective flow areas. All right, so what I have on the screen here is my HEC RAS. I'm going to start by going File, New Project. Since this is an exercise, I'll be running through all the steps, and then let's give our project a name and also navigate to the directory we want to store that project in. So I'll just call this exercise 8 and then click OK. Okay. Down here is my geometric data. So you can open that up by going Edit Geometric Data, or just click on this button right here, View/Edit Geometric Data. Let's go ahead and get started by sketching out a river reach. So I'll click this button for Tools, River Reach, single left click, and then drag down, double left click, and then let's go ahead and give that river and reach a name. River A, Reach 1. Okay. And then next, let's go ahead and add a couple cross sections. So I'm going to add a cross section at the bottom of the reach and at the top of the reach. Cross section data. And then I'm going to go Option, Add New Cross Section. This will be at River Station 0, so at the bottom of the reach. And then I'm going to type in some data here to define the cross section coordinates. So 0 and then 90. 100 over will be down to 60. And then the last coordinate here is at 1000 back up to 90. All right, the downstream length will be 0 because this is the cross section already at the bottom of the channel, at the bottom of the reach. Manning's N, I'm going to say is 0.03 and 0.05 for the main channel and the overbank, respectively. And then the main channel bank coordinates I'll put at 300 and 700. So when I click Apply Data right here, we'll get a little preview. Keep in mind the scale is not the same. It's linear, but it's definitely stretched out in the vertical dimension. All right, let's go ahead and add a cross section to the top of the reach now. The quickest way to do that, I think, is just go Option, copy the current cross section. This is going to be at River Station 10,000. I'll click OK. And one thing I need to do now is just increase the elevation of my cross-section coordinates. So I'm going to add 20 feet to all of these values for a average channel slope of 0.2%. Options, adjust elevation. I'm going to say 20. Okay, those values got added. And one other thing I have to do here is add the downstream reach length. So it's going to be 10,000 down to the bottom of the reach. And then click Apply. All right, so if I go plot, I can see the profile. So there's the slope right there. That looks good. Apply data and close. Now I have the two different cross sections on the river channel, as you see here in the geometric data. I'm going to save this geometric data file as sort of a base file, which I can refer to later. And then we can make copies or modifications from this base file. So I'm just going to call it base, B-A-S-E, and OK. So I have base right here. Next, let's go ahead and add some flow. So I'm going to go Edit, Steady Flow Data. And then what I'm going to do here is for my profile, I'm going to use a flow rate of 156,000 CFS. You'll see why I'm using that number in just a moment. And then for the boundary conditions, I'll set that to downstream normal depth and then the channel slope of 0.2%, or as a decimal, 0.002. So I'll click OK there, and now I need to save this file, save the flow data. I'll just call it 156K for the flow rate, and OK. All right, we're ready to create a plan and run the steady state simulation. So I'll close this, we'll go Run, Steady Flow Analysis, and then here I already have the base geometry loaded, and then the 156,000 CFS flow rate also loaded. What I want to do is go File, Save the Plan. I'm going to name it base underscore 156K and OK. Same thing here for the short ID. And then let's compute. Okay, so that's done. Let's go ahead and take a look at the results now. View, cross section. And as you can see, I chose 156,000 CFS on purpose because the water comes right up to the top of the main channel, right up to the bank station. In fact, it's very close. I'm zoomed in quite a bit here. You can tell from the elevation that I have, let's see, 80 feet looks like the elevation of this overbank. And the water surface comes up to 79.94 feet. So I only have about 0.06 feet of freeboard here, which is like half an inch. And let's just confirm that with the table. So if I go view and then profile summary table, we have the water surface elevation at 79.94 and 59.93. So remember that the overbank elevation at these two stations is 60 and 80. As we can just confirm at the river station 0, it's 60. And then, yeah, 80. Okay, so I'm going to close that up. So what I want to do next is go back to the cross section and modify this geometry file to create a side channel in one of the overbanks and demonstrate what an ineffective flow is by running a simulation with and without ineffective flow. Okay, so the first thing I want to do is actually save a new geometric data file. I'm going to go File, Save Geometry Data As. Now remember, this is the base that we're saving from, so I'm just going to give it a new name. Left channel is what I'll call it, and I'll click OK. All right, let's go ahead and make some changes. So this is the data right here. Here are the coordinates. What I'm going to do is actually demonstrate real quickly Tools, Graphical Cross-Section Edit. So this editor allows me to select the river reach and then also do a number of things from this options menu. I'm going to add station elevation points just by clicking right here. So if I click and then click again, and then say click here and then click again, I can also go options, move objects, I believe allows me to drag the points themselves. So I'm dragging the points there. Don't worry about the water, that will be recalculated in a little bit. So I guess that saves automatically. Close that. If I go back to the cross section, you see that we actually have 4 new points here that define this little side channel in the left overbank. I'm calling it left channel. I'm really not too fond with these numbers though, so I'm going to just manually change them. So instead of 134, actually I'm just going to delete these out. I could have also just gone straight to the table and then click insert table, insert row, and delete row. But I wanted to show that graphical cross-section editor briefly. All right, so I'm going to go 150, 60, 160, 45, 240, 45, 250, and back up to 60. So when I click apply data, boom, I have this side channel right here, which looks a little bit artificial and not too natural, but it's all right. This is just an exercise. What I want to do is the same thing, make the same changes, but for the next cross section up at the top of the reach for the 10,000 foot river station. So I'm going to toggle up, go ahead and highlight this row where I want to insert some rows. So I'll go insert row and then 2, 3, 4. That looks good. I'm going to type in 150 for the same station, but now 80, 160, 65, 240, 65. All right, let me click apply data and make sure I have a similar looking left channel over here. All right, let's go ahead and run the simulation using the same 156,000 CFS and then check out what happens. So let's close this. Let's go File, Save the Geometry Data. And then at the top, I'll click on Run Steady Flow Analysis. Now it already has my left channel geometry defined, but not a plan. So this is exactly what I want for geometry file, steady flow file. I just need to name the plan now. File, save the plan, and then I'm going to call it left channel underscore 156. Click OK, and then we'll call that the same thing there and compute. Okay, so that's done. Close. Now I'm going to go view cross section. And now if I zoom in a little bit, there appears to be a little bit more freeboard here. So I've got, let's see, 80 feet down to 79.1 approximately. So still less than a foot of freeboard, but I mean, probably 9 or 10 inches. Now it should be the same height over here at the side channel. Here's the left channel right here. And yeah, it looks like it's the same water surface elevation. So let me go ahead and close that. And then profile summary table. Here are the 2 different cross sections, and it looks like the water surface elevation is 79.08 and 59.08. So there's 0.92, 0.93 feet of freeboard. Now, so far, we have not added any ineffective flow areas. The purpose of the ineffective flow area is to prevent flow in this side channel if the water surface hasn't already overtopped the area between the main channel and the side channel. I think I said that right. So let's go ahead and add an ineffective flow area. Before I do that, I'm going to save a separate geometry file just so I can keep different geometry files saved separately and named properly so we don't lose track of things here. So File, Save Geometry Data As, and then instead of left channel, I'm going to call this left channel underscore IFF for ineffective flow. It's the name I came up with, so we'll go with that. All right, so now we're editing this left channel IFF geometry file. I'm going to open up the cross-section data editor and then go to options. And let's see, ineffective flow areas. Now there's a normal version here and multiple blocks. I don't need multiple blocks here. I just need one left ineffective flow station. So I'm going to go, let's put this at 300, which is currently the left overbank station. So 300 there. And then the elevation is going to be 80. And it doesn't need to be permanent. I'll just click OK. Now you can see the green hatching for the ineffective flow area. What that means is that it'll still fill up with water, but it won't actually convey flow. And we'll see that because the water surface elevation in the main channel will be back up to where it was in our first simulation run, which was just, 0.08 feet from the top. So it was just almost at the top. It was 79.93 feet or something, or 59.93, depending on which river station cross section we're looking at. According to this preview, there is a little green line and triangle icon to represent the ineffective flow. And it's kind of hard to see, partially because the bank station icon is at the same location. But if we wanted to be a little bit more dramatic with things, I could add a higher elevation than 80 feet. So if I pumped it up to 90 feet, we should be able to see it in this diagram a little easier. Let me go ahead and do that just to demonstrate. So let's make it 90 feet and then OK. Apply data. Okay, there it is. So now we see the green ineffective flow area, but this is not what I want. I just want to put it right at 80 feet. So I'm going to go back, ineffective flow areas, change it back to 80 feet, and OK, and apply data. Now I want to do the same thing downstream at the 0 river station cross section as well. So there we go. Options, ineffective flow areas. This will be at river station 300. The elevation will be 60, not permanent. So, okay. And it's right there. We see the hatching pop in place and apply data. All right, looks good. So let's close that up. File, save geometry data. Now let's do one final simulation run here with our ineffective flow areas in place. You can even see the green dot in the plan view here from above in the geometric data window briefly. So we'll go run steady flow analysis. I already have the geometry file loaded in. I'm going to go ahead and give this plan a name. So save the plan, and it's going to be left channel ineffective flow 155,000 CFS. And click OK. Same thing here. OK, and compute. Okay, that looks completed. Let's click close and take a look at the results now. So we'll close that. We'll go view, look at the cross-section data. Now we see the hatching here for the ineffective flow area, but I really need to zoom in or look at a table data. And we're back to where we started, where we have 0.06 feet of freeboard. So we can tell that all of the flow is in the main channel and none of the flow is in this side channel off to the left bank right here. So the water surface is up to the top or nearly the top, but there's no actual conveyance of flow. So let me go right click, full plot, and that should be the same up at the top cross section as well. If we want to look at the numbers, we can go view and profile summary table, even though it says profile output table here. And we see the water surface elevation here is 79.94 and 59.93 with just 0.06 and 0.07 feet of freeboard. All right, well, that was it for this exercise. It was a quick exercise just demonstrating ineffective flow areas in a river reach in HEC RAS.